Hey everyone, welcome back to my channel. Today we are covering the sliding window algorithm, one of the most asked topics in coding interviews, and honestly, one of the most satisfying once it clicks. So look at the screen. We have an array 427, 385, 61 and the window size k equals 3. The question is simple. Find the maximum sum of any three consecutive numbers in this array. That is it. That is the problem. Now, there are two ways to solve this, a slow way and a fast way. Let me show you both. Look at this comparison on screen. Left side, brute force. For window 1, we add 4 plus 2 plus 7, that's 13, fine. For window 2, we move one step and add 2 plus 7 plus 3, that's 12. But notice something, we calculate 7 twice, once in window 1 and once in window 2. For window 3, we add 7 plus 3 plus 8, we calculate 7 a third time. The bigger the array, the more we repeat this work, that is O of n times k, slow. Look at the right side sliding window. Window 1 sum is 13, fine, same as before. Now to get window 2, instead of adding everything from scratch, we just remove 4 from the left and add 3 on the right. 13 minus 4 plus 3 equals 12. Done. One subtraction, one addition. Window 3. Remove 2, add 8. 12 minus 2 plus 8 equals 18. We never recalculate 7. We reuse the previous sum every time. That is O of n. One pass through the array, that is the whole point. Now watch this. I'm not going to click anything here. Just watch the screen. See that frame moving across the array. That is your window. It is always k elements void. It never restarts from the beginning. It just slides one position to the right. Every step, j moves to a new box on the right side. That box flashes green. And when the window is full, the leftmost box flashes red and falls off. Watch the sum at the bottom updating live. And watch the best value every time we find a bigger sum. It updates. That's the whole algorithm. Visually, that is what sliding window does. A frame moving across your data, one step at a time. Okay, 4 bullet points. This is everything you need to remember. 1. J always move right. Every single loop. No condition, no exception. J just walks forward. When j minus I plus 1 equals k, your window is exactly full. That is your trigger. That is when you act. 3. Once you act, subtract array of I and increment I. That is how the window slides forward. 4. Total operation equals n, not n times k. That is why this is fast. Before we look at the code, let me answer one question that trips everyone up at the start. If the window starts at index I and ends at index j, how many elements are inside? Most people say j minus I. That is wrong. Let me prove it. I is 0, j is 2. The highlighted boxes are at index 0, 1, 2. Count them. 1, 2, 3. 3 elements. If j minus I, that is 2 minus 0, equals 2, but we counted 3. Look at the screen. The red row shows j minus I equals 2 with label counts 2 gaps off by 1. The green row shows j minus I plus 1 equals 3, correct. Now I is 3, j is 6, boxes at index 3, 4, 5, 6, that is 4 elements. J minus I is 6 minus 3 equals 3, wrong again. J minus I plus 1 is 6 minus 3 plus 1 equals 4, correct. One more extreme case. I is 1, j is 7. That covers almost the entire array, 7 elements. J minus I is 7 minus 1 equals 6. Wrong. J minus I plus 1 is 7. Correct. So why the plus 1? When we subtract I from j, you get a number of gaps between indices. But you do not want gaps, you want boxes. And boxes are always one more than the gaps between them. Simple as that. Always j minus I plus 1. Now, here is where the fun part is. On the left, the live array with I and j pointers. On the right, the actual Python code. I have k set to 3. Let me click through step by step. J moves to index 0. Look at the code. The line window sum plus equals array of 0 lights up green. And the comment says array of 0 equals 4. Window sum equals 4. The check if j minus I plus 1 equals k lights up orange. The comment says 0 minus 0 plus 1 equals 1, which is not equal to k, which is 3. So we skip. Then j plus equal 1 lights up. Comment says j 0 to 1. Next step. Now j is 1. We added 2. Window sum is 6. Size is 2. Not fully yet. Now j is 2. I is 0. J minus 1 equals 3, which is equal to k. The window is full. Look at the code. The check line turns orange. Then, if window sum is greater than best, turns blue. Comment says 13 is greater than negative infinity. Yes, so best equals window sum. Runs. The best is now 13. Then the red lines fire. Window sum minus equals array of I. Comment says array of 0 equals 4. Window sum becomes 9. Then I plus 1 equals 1. I goes from 0 to 1. Window slide forward. J moves to 3. Sum becomes 12. Window check fires. 12 is less than 13. Best stays. J moves to 4. Sum becomes 18. Window check. 18 is greater than 13. New best. Watch best update to 18 at the top. J moves to 5. Sum is 16. Less than 18. J moves to 6. Sum is 19. 19 is greater than 18. Now new best again. 19. J moves to 7. Sum is 12. Done. Final answer 19. That was the window covering 8, 5, 6. Look at this table below. Every step we just did is recorded here. Ji, the window contained the sum, whether the window was full and the best so far. This is your dry run. In an interview, if they ask you to trace through the algorithm, this table is exactly what you write. Step number Ji, window sum best. Notice how best only updates on the rows where j minus I plus 1 equals k. The green checkmark rows. Everything else is just building up. Now this section, these are real problems from LeetCode and interviews that all use the exact same template we just built. Easy ones, maximum sum of size k, minimum sum, average of subarrays. For this you literally copy the template and change what you track inside the windows. Medium ones, first negative in every window, count anagrams, maximum of all subarrays, same template. You just add a data structure inside, a queue, a frequency map, a dequeue. Hard ones, add constraint on top of the window logic. The pattern is identical. You change the window size, you change what you track. The skeleton never changes. And that is it. Sliding window. The three things to lock in. J always moves. J minus I plus 1 is your window size. And when the window is full, you record your answer, then slide I forward. If this video helped you, smash the like button. Subscribe and hit the bell so you can get notified when the next video drops. Add or drop a comment below. Tell me which problem from that grid you want me to solve next using exact template. I will see you in the next one. Peace.